Hey everybody, Joe from Great Bench Electronics here. Welcome back to the bench. So I have another Smallsound Bigsound Mini in need of repair. I've actually repaired another Mini in the same pink colorway before on the channel. I'll put a link to that in the corner right there. That other Mini wasn't too bad. It just had a foot switch issue, I believe. This one is considerably worse. The original owner of this pedal told me that initially had some issues with the pedal. I don't think they elaborated on that, but then they handed it off to a coworker who said they could fix it, and that coworker did quite a number on it, as you'll see in a second. So we're going to try and get this pedal back in working condition and also make it look at least decent. It will never look, completely original by this point, but as you'll see in a second, it looks pretty bad right now, so we're going to try and remedy that. I've also done a teardown on the Smallsound Bigsound Mini. I'll put a link to that in the corner now if you're interested in my breakdown of this pedal. Today we're just doing a repair. So on the external here, it's not too bad. It does look like, I'm not sure about this gold. I don't know if that was paint afterwards or maybe that's something underneath the original Smallsound. I don't think so. It looks like it's over top of the black graphic here, so I'm not sure where the gold color is coming from here. The original pedal, I'm pretty sure, did not have that. Otherwise, it's pretty standard. Smallsound Bigsound Mini has gain, volume, bias in the middle, bass and treble. On the back, a couple pieces of Velcro, side mounted jacks, 9-volt DC jack. Foot switch actually feels nice. It's lower actuation than the standard blue ones. Just judging from the looks inside, we're probably going to be replacing that anyway, but it does feel okay. Let's go ahead and take this apart a bit, and I'll show you what we're dealing with. Alright, so here is the inside of the pedal. All of the original white wire, this white wire is original stuff from Smallsound Bigsound. That's been replaced with this black wire. The solder joints are, I'm just going to come out and say it, they're terrible. They're really bad. The solder joints here on the foot switch, this is a replacement foot switch PCB. You can see those are all cold, not flowing into the joint. There's excess wire coming out of the solder pads. All the joints have that sort of hazy look over them to show that they're not properly flowing to the solder pads underneath. In here we have like excessive wire coming out of the pad that's not being protected by the insulation on the wire. Over here, this little extra piece on the wire right there is a 1/4 inch long for unknown reasons. It looks like potentially this electrolytic capacitor was damaged. At least the outer shrink wrap was. Luckily, the potentiometers seem pretty much untouched. The DC jack been rewired as well, so everything connected with wires to the foot switch obviously had to go because we replaced the board. The input and output jacks seem okay, but need to be rewired. So we're going to redo all the wiring for the foot switch here. And then hopefully that brings the pedal back to life. Honestly, I didn't even try and plug in power to this because I don't trust that it's not going to short or do something wrong. We got a lot of exposed wire in here flying around, a lot of burnt and melted insulation on these wires that may be shorting out. So when I see something as wrecked as this is, I don't even apply power to it because it's just not worth risking the more sensitive electronics on the board here. So let's just get this thing apart and we will start taking these wires all out. Hopefully we can, the real concern here is saving the main PCB here. The foot switch PCB, hopefully we can save that as well, because I don't think I have another like generic replacement PCB for the foot switch, but those can be had. The PCB for the actual pedal, that's where the real concern is. And now some of these pads for the wires, they've been heated up once for original build, second when these wires are replaced, and now this will be a third and a fourth time of removing wires and installing new wires. So we need to be very careful about trying to protect the copper on this PCB. Now that I've got the pedal out of the enclosure, you can really start to see how poor the soldering job and the wiring job is on this. I tend to err on the side of not bashing other people's work because you never know where people are at in their journey as like an electronics repair person or a pedal builder or whatever. And, you know, I'm not going to say that when I first started soldering, I did much better work. But when you are repairing a pedal by someone who builds this stuff by hand, like Brian does, or at least did, I hope. I'm not sure actually what the situation is, Smallsound, Bigsound, but regardless, these were hand-built pedals. They were not cheap when they were new. They're not cheap if you want to go buy one right now. To take this, not only take this and do it to one of your own pedals, but to do it to someone else's pedal, it sucks. And yeah, this, I'm not sure who this person is, but they shouldn't have taken on this job, and they shouldn't have offered to fix it for anyone. So hopefully we're going to be able to put this back and get it in working condition. First step is going to be actually cataloging where everything is connected. My concern is that I won't be able to read the print screen. The 4 solder pads here are the wire connections for the foot switch, and we have the DC connections over here in the corner. They are printed on the PCB, what they are, but I'm worried I won't be able to read it. I just can't read it now with all the solder and flux and extra crap covering it. Usually what I do here is I'll take a piece of paper like this, and I'll try and write out what they are so that I don't lose track of the connections. In this case, these ones are easy enough to read. We have ground in the corner and 9 volt, positive 9 volt here. So that'll be connected to the DC switch. I just cut that out to make it easier to remove. And we're just trying to determine what these 4 pads are here. In terms of what they're connecting to right now, okay, now I just had to look at the diagram for the breakout board here. So in order, these are output jack, circuit out, ground, positive voltage. It has connections for an LED, so you have voltage in here. Input, circuit input, and input jack. Okay, right off the bat, I can tell why this didn't work. They have one of the jacks connected to the input I, which is supposed to be the circuit input, but it's wired to the input jack. I think that's the input. Actually, is one of the jacks. Is definitely not correct. And then IJ here, this wire is connected up to the board into the corner. Let's double check that to make sure that's right. Yeah, so that should be the input jack. That should be the input to the circuit. So that's there. So we're going to call this in. Hopefully that's correct on the PCB at least. And then this is the input jack. So we'll ignore that because we're marking the PCB right in here. This wire, those are almost definitely shorted out. I can see wires connecting right there. This is rough. Okay, so that's coming here to ground. Okay, so they have ground is connecting from the ground pad here to the second from the right pad here. This wire is connecting here to this looks like the switch for the LED right there is that one. So we'll put LED, and this wire then is coming over here, and that's the far one for output jack, of course. And just to confirm that they did it wrong on both sides, yes, they did. So this is out. That's how they have it wired for these connections. We're gonna have to double check that because who knows if they even got that part right. So we're gonna take the wires off the PCB now. Like I said, want to be really careful about heating as little as necessary. One thing that's a good idea when you are moving wires and you're concerned about the copper on the PCBs deteriorating or lifting, pads separating, is actually to cut the wires pretty short because the wires act like heat sinks and they pull heat away from the PCB, and that's not what we want. We want the heat to stay here to keep that solder liquid so that when we pull on it, we're just separating the inner wires from the liquid solder on the board. If that solder starts to solidify, that's when it sticks to the copper and pulls that out of the PCB, actually starts pulling the copper. So we're going to cut these wires nice and short. We'd still want to leave a little bit that we can grab on, like with needle nose pliers, but still going to cut them nice and short here. Right. Luckily, it looks like they didn't really touch the rest of the PCB, which is good. All right, we're going to try and get these out of here without damaging the PCBs anymore. This one was just sitting on top of the pad, not even in the hole. Same for that one. Okay, that one came out pretty easy, which is good. Let's turn this one heat a little bit from the other side. Sometimes counterintuitively, it actually helps to add a little bit of solder. Get that heat in there. Okay, that one came out nice. You can see how dry the pads are for these wires. I'm going to give this one go with the solder wick, and then if not, we're going to pull out the solder pump. See if we can just wick away this excess solder. No, it's not happening. Maybe got that one. Maybe this one on the end. There's a lot of like black crud left over on these pads from the insulation on that wire. Some alcohol can help clean that up a bit. So there's still a little piece of wire left over. Alright, I didn't want to have to, but I'm pulling out the solder pump. Alright, let's see if we can clean these up a little better here with the pump. These ones are good. Alright, I cleared out those two ones on the ends, but we still got extra little bits. Still got a little bit of wire left over in these pads. I'm going to try and push it out. Actually, the ideal thing here would be a solid lead on something small enough to fit through there, but these holes are pretty tiny. Actually, my 1/4 inch resistors don't fit. Let me just check and see if I have resistors. Generally I go for the KOA spear resistors, which do sometimes have thicker leads. Let me see if these, well, actually that'll work better. So I'm going to actually use the lead of a resistor here to try and push that out. Heat here. Got this here. Okay, let's push that in. Let's just get that off, and then heat it out. Let's get off that. That's there now. Okay, now hopefully we'll be able to successfully use the solder pump to pull the rest of the solder out of those holes. Alright, so I believe these are all clear now. It's good, good. Alright, let's see if we can just clean those up a little bit more. I'm definitely not liking the look of this capacitor here. It looks pretty burnt / gooed up, and I'm just thinking I might want to just replace this just in case there's something wrong that I don't have to come back in here and take it all apart again. I don't have an exact match in terms of size for this capacitor, but I do have these high quality Panasonic 10 microfarad 50 volt capacitors. 50 volts is way overboard, which is fine. That should be an acceptable replacement there, and they're still black at least, so these are probably 35 volt ones, a little bit shorter. It's unbelievable how much easier removing parts is with a solder pump. Kind of can't believe how long I waited to get one of these. Look at that. Easy. It's not going to come completely clean. I think it's actually stained the board, but All right, I cleaned it up as best as I can. I'm not going to spend an hour on that. A lot of the goop is like plastic, which is not going to come off just with isopropyl alcohol. So we'll put in our new cap, make sure our polarity is correct. The caps are there. And I can see now on the silk screen that the wiring on the PCB was correct to what the wiring that was done for this recent repair-ish was done. So it's circuit in, ground, LED, and circuit out. So we're going to use some 24 gauge pre-tinned wire here. I'll trim these a little bit long just because you shouldn't need that long, but we can always shorten them. Here. I think that through hole there is a little bit damaged because it doesn't want to go through cleanly. Just going to touch up some of these here just to make sure we have good seating for all these wires. Okay. Right. And then I'm going to do a little trim here. It's like a little bit. A little short coming. I'm manipulating the wires back and forth a little bit here because I'm not sure what the plating condition is on these PCBs, so I'm going to make sure I get solder on both sides. So there's all 4 of our wires. We'll make sure we'll be connecting those to the correct spots on the foot switch. Let's go have a look at that now. All right, as you can see, the foot switch is in dire shape as well. My hope is that I'll actually be able to get the foot switch out of here because, as you can see, it's actually one of the nice Love My Switch foot switches that I use all the time. So it's like a $4 or $5 foot switch that would be really nice to be able to continue using. But I'm going to try and wick away some of this ugly solder, and hopefully it'd be nice to get in there and actually clean the PCB, but I don't know if we're going to get that. I'm going to come in here and take my own advice. Clip off the extra pieces of these wires so they don't act like heat sinks while I'm trying to desolder these things. That's good. Try and make a blade solder on these lugs of the foot switch here. If you're wondering why the solder ended up looking that bad, or the soldering, it's going to be partially due to the skill of the solderer, but it's also the choice of the materials. That to me is a clear sign, the way the soldering has gone, of not enough heat. Having a soldering iron that can put out the necessary amount of heat, not just in temperature, but in like quantity of heat. There's probably a measure of that I don't know, or unit. But being able to deliver that heat into the PCB, into the lug, into your solder, and maintaining it so that the solder can flow where it needs to flow is really important. And this is a sure sign that not enough heat was used. In addition, having good rosin core solder, the rosin will push away the impurities from the the copper on the PCB. But part of the skill of being able to assemble this stuff is to recognize when it's not going well and to stop and hand it back to the person and say, hey, this isn't for me, or get some advice or something. One of these bad joints should have been enough to say something's not right here. Doing it 9 times and saying, yeah, this is solid, it's just not acceptable. So I'm trying to do a 2-part thing where I'm wicking away some of this ugly solder and replacing it with good solder. I don't think I'm going to be able to get this out of here. Or get the foot switch out of the PCB, I mean. So I'm going to hope that the PCB, it's still in good condition and I can just flow new solder into here. But right now I'm just trying to get out as much of this old solder as I can. I'm going to pause here for a minute or two, let it cool down, because I just put a lot of heat into the PCB and the foot switch. All right, I'm feeling cautiously optimistic about that. I'm going to clean this up a bit while it's cooling off. It's a lot there. Come here. Sorry, no. Give it a couple minutes, let it cool down a bit more, then finish soldering. And that's how that's supposed to look, where you have nice even domes, or some people call them fillets, going from the PCB up to the lug. It should be even, there shouldn't be blobs. It should look clean. It helps that I'm using no clean solder. Anyone curious, the solder I use is Kester. The part number is 24-6337-8800. It is 0.8 millimeter or 0.031 inches. And it is a 63% tin, 37% lead mixture. And it has rosin core solder. So run through the middle of this 0.8 millimeter solder is rosin, which helps clean the solder joint, helps push away impurities, and as the solder cools, it forms a film over it to protect it from oxidation. And just for the icing on the cake, as I'm doing the DC jack, what would this be? This would be the positive connection for the DC jack is not even soldered on. So that's cool. Can't imagine why it didn't work. All right, so we got the components all put back together now, hopefully wired correctly. I did switch the input and output jacks, like I'm using what was the input jack for the output jack and vice versa, because what used to be the out jack but is now the input jack has this burn mark, and I was able to hide that underneath. At least that's the plan. I didn't film it, but I extended these DC jack wire connections. They were just a little bit short, so these are like 2.5-inch wires now. Let's drop back closer. Even on the original pedal, these are awkward to reassemble. I'm not going to tighten down this foot switch until we get the DC jack soldered here. Nothing short now, nothing's pinching. It's tight, but it does fit. Okay, so that's cool. Just going to get this DC jack wired in here. And we're just going to double check that. We'll touch the pin inside here, and that should be ground, not the positive. Ground. Yep. So that's ground. The pin is ground, not the power. And then the ring on the DC jack is the positive. Right. So that goes up. Jack. Very good for that. Easy. Right, so we go. Just down. Okay. Well, that looks way better. Hopefully the foot switch still works and didn't get overheated. Just going to touch up a couple of the solder pads here for these wires. Okay. Good check here. All right. LED works, which is good. So I suppose we're ready to just plug it in and do a quick little listening test. All right, set up for a listening test. Just got a little Yamaha practice amp here. Cool. Sounds like it's working. Got to put the knobs back on and we'll button it up, and then I think this thing's good to go. All right, so knobs going back on. These smaller knobs, they have the correct shaft mounting for the bass, treble, and bias. However, the gain and volume knobs, they use these larger knobs, and they have standard like set screw, but these are the knurled knobs that work by tension, and you can see they've sort of been crushed in. I think they might have came this way actually from Smallsound, Bigsound. I can't be certain. I don't think this is the person who redid this, although I'm not sure. But I think the correct solution here is to use a brass sleeve to actually give the knobs something to bite on. Right now I'm just sort of widening these back out a little bit so that they accept the brass sleeve. I'll show you what I'm talking about. Yeah, these things, these are just little thin-walled brass tubing cut into the shape here, and they slip on top of these knurled posts unless they have been squished in like this, in which case they don't fit that well. So I'm going to try and just gently widen these out so that they actually grab the brass here. And then these little pieces of tubing give something better for the set screws to bite on when you cinch these down, instead of just smushing these posts together. You do have to be careful doing this though, because if you break one of these off, then it's over. You have to replace the potentiometer. I don't want to go too much further with those. And then we'll come in here in a way that they hopefully won't come off. I believe you can get these from Love My Switches. At least I think that's where I got them. All right, so there we go. That is one repaired Smallsound Bigsound Mini. Much more extensive repair than the previous one I did. We had to rewire the whole foot switch, replace all the wiring for that, and the input-output jacks. Luckily, the circuit, for the most part, wasn't messed with, which is good. We did replace that one capacitor because it was pretty ugly. It might have been working okay, but it's just one of those things where you swap it out because it's not worth it to like put it all back together and figure out that it's not working, just have to go back in again, when I can just quickly, you know, zip, take it out, replace it, and then you don't have to worry about it. So happy to say this Smallsound Bigsound Mini should be good to go for another who knows how many years until it needs repair. Probably going to be the foot switch, and then who knows, maybe it'll be back on my bench. Either way, if you enjoyed the video, I'd appreciate you watching. If you have any questions, feel free to leave them in the comments. If you enjoyed, I appreciate it if you like and subscribe. I'm Joe from Great Bench Electronics. Thank you for watching.